Hi everyone. This is your homework for March 2nd, Thursday. It is called Drawing Inferences from Data Sets. To be able to get good at this takes time and practice. And the best way to get that is by looking at examples and examining them closely. Here are some examples of what I'm talking about. I'm going to read the first few to you, and then we'll figure out what we can draw inferential-wise from them as we go along. A carpenter has accumulated a large collection of nails, screws, and bolts, which he had randomly thrown together into a bucket. Later, he wanted to estimate how many of each he had. To do this, he grabbed a handful from the bucket. His results are shown below. Based on the information presented, can you infer anything about the relationship between the number of nails, screws, and bolts in the bucket? All right. To do this, look at how many, first of all, let's look at his samples. The samples refer to how many times he pulled stuff out of the bucket, and he did this 7 times. Each time that he did this, he gathered information about the quantity of how many nails, screws, and bolts he had. In sample 1, he had 19, 20, and 19. In sample 2, he had 18, 19, 20. Sample 3, 19, 20, and 21. Sample 4, 19, 22, and 21, and so on. The question then asks, based on the information presented, can you infer anything about the relationship between the nails, screws, and bolts in the bucket? Well, okay, let's look at it. When you look at each of these samples, is there a big range from the smallest to the largest numbers? And when you look at that going across, the answer is no. Therefore, the inference that you can draw is the number of nails, screws, and bolts are about equal. There's not a statistical difference between those 3 items that are located inside the bucket. Let's look at number 2. For a canned food drive, there were 3 types of canned vegetables donated: peas, carrots, and green beans. To estimate how many of each type were donated, you pull out a sample. The results are shown below. In sample 1, there were 4, 4, and 3, and in sample 2, there was 3, 3, and 4. Based on the information presented, can you infer anything about the types of cans donated? Again, look to see if there is a statistical difference between samples 1 and samples 2. And when I look at this, I see that there is not a difference. Therefore, the number of the types of cans are about the same. They don't have to be perfectly the same, but they are about the same. Let's look at question 3. In a library, there was a donation box for books. A librarian wanted to estimate how many fiction and how many nonfiction books were in the box, so she pulled out a sample. The results are shown below. Based on the information, what can you infer about the books donated? Okay, let's look. And there were 6 samples taken, and of the 6 samples, that is your fiction number, and here is the non-fiction number. All the way across in the fiction, you have a fair number more than you do non-fiction. In sample 1, the difference is 8. In sample 2, it's 7. Sample 3, it's 9. Sample 4, it's 5. Sample 5 is 4. And sample 6 is 10. Now, this one's small, and so is this one. But what you can say for sure is that there are more fiction books than there are nonfiction. Let's look at question 4. Now we're going to change a little bit. Instead of looking at inferences, we're going to look at samples to determine what type of we're looking at or what type of data set we're beginning to look at. A beverage company wanted to see if people in the United States like their new logo. Which choice best represents a population? A selection of logo artists, a selection of shoppers from different states, 189 male and female employees, every person in the United States. Okay? The beverage company is looking to see if people in the U.S. like their new logo. So when you look at this, which would be the best representation of the data that they're looking for? If you look at a selection of logo artists, they're only talking to people who made logos. That's not going to work. If you look at a selection of shoppers from different states, that could work. So we're going to leave that alone for now. If you look at 189 male and female employees, employees means you work there. That's not going to be exactly fair. And then every person in the United States. Well, that could be, except does every person in the United States drink this beverage? With that information, B would be your best answer. Let's do two more examples here. A toy store owner tracking how much kids spend each month on toys. Which choice best represents a sample? And remember that you want a sample that is not biased and that it is representative. So, 264 boys and girls in the toy store, all the kids who buy toys, 257 boys ages 7 to 15, or 211 rich kids. If we're looking at best, what do you think it would work? First of all, it says a toy owner tracking how much kids spend each month on toys. Kids who spend money buying toys. So, the best sample for this person would be the 264 boys and girls in the toy store. This is because it's the toy store owner asking the question. Not all people who buy toys are rich. You wouldn't only just ask boys. And not all kids who buy toys are going to buy all of their toys from one specific place. Lastly, let's look at this question. This is a repeat in here, so I'm going to cross that out. I apologize for that. Let's go to your homework questions. I'm going to read these to you, and then I want you to answer these questions, and then make sure that you bring this in. During a class election, a teacher wanted to predict who would win. To do this, she took a sample of students from each class and asked who they would vote for. The results are shown below. Based on the information presented, can you infer anything about who will win the election? In number 2, a pizzeria owner was trying to determine which types of meat he should stock the most for his new store. To do this, he asked several pizza eaters what their favorite toppings were. His results are shown below. Based on the information presented, what can you infer about which type of meat he should stock? Question number 3. An ad agency was trying to determine if customers like blue, green, or red packaging better. To do this, they took a sample of customers and polled them. The results are shown below. Based on the information presented, can you infer anything about which color is liked the best? Question number 4. A musician wanted to see what people who bought his last album thought about the songs. Which choice best represents a population? Every person from age 5 through 12 who bought the album, a selection of 3,701 people who bought the album, a selection of people who didn't want to buy the album, or every person who bought the album. A gaming website, number 5. A gaming website wanted to find out which console its visitors owned. Which choice best represents the population? All the website visitors, visitors with an E in their username, visitors over 23, visitors in the 3D section. And I imported something wrong on my iPad. I apologize. So, of course, you can disregard that. So you have a total of 5 questions. Come prepared in class tomorrow. And be sure that you're working on your IXLs that you have missed. Remember that your priorities are DD1 through DD5. CC1 through CC4 and finish the M's if you haven't done so. Thank you.